All right, so last idea from 11.3. This is actually more of something that I want to extend on, because what we're going to eventually be doing here is talking about graphing a quadratic function. And we're going to take a long look at it, but there is a graphical connection to this. And that connection is when we're asked to find x-intercepts. So when we're asked to find x-intercepts, as we've seen in the past, I'm essentially setting y, or in this case f of x, equal to 0. So in all these cases, I would have to take all these functions, if I already did it there, and set them equal to 0. So what I'm basically doing is solving a quadratic equation. And what we saw is that we can solve this by using the quadratic formula. So these were the first 4 examples that I did, and we already know the solutions. So here the discriminant was nice. It was a nice square. We ended up with really nice solutions. But as far as x-intercepts go, that means that we are crossing the x-axis at these 2 nice locations. Same thing here, right? So when I set that equal to 0, the discriminant ends up being the 17. So we end up with 2 very nasty looking irrational zeros. And so I still have a couple of x-intercepts. Let me go back to my notes here, and I think, what did I say? Let me kind of find that other one. Where are they at? I think we found this one to be like negative 0.0140, and this one was like negative 1.520. So again, I have 2 nice locations. Well, not nice, but I definitely have 2 x-intercepts here. So because we have 2 real solutions, whether they're nice or not nice, I'll end up having 2 x-intercepts. Okay? On this next one that we looked at, we ended up getting a discriminant that was equal to 0. And what happened when it was 0, we ended up with just 1 real solution. So that means that as far as crossing the x-axis, this graph only crosses the x-axis 1 time at the location 5, 0. And then the next one that's a little tougher is we ended up having a situation when I set that equal to 0, the discriminant ended up being negative 8. And doing some simplification, we got x equals 1 plus or minus I squared roots of 2. And this is not even real. And when I graph something on my xy plane, this is based in reality. All right, and so these points, these data, if you would, these complex zeros wouldn't show up on my picture. So what this basically means for us here, there are no x-intercepts on the graph. So my graph never crosses the x-axis. All right, so that's the graphical connection. And what we also know from previous knowledge is that quadratics, right, they're basically going to be a U-shape opening up, or a U-shape opening down. For reasons that will be clear in the next chapter, these are all parabolas that are going to be opening up. And since this has no x-intercepts, that means this graph is doing something like the following, right? So it is basically not crossing the x-axis in any way. All right, so we've got that. As a matter of fact, let me double check my work here, because I think I screwed something up in terms of an example. I might have miswrote something. That's a plus right there, I'm sorry. So plus 3. So something looked a little weird there. So yeah, so x squared minus 2x plus 3 had complex zeros. So it's a parabola, it's a U-shape opening up. Since I know it's never crossing the x-axis, there's a potential graph of what that looks like. So notice that this U-shape never crosses the x-axis. In this next one, since again we have a U-shape and we know we're crossing at 5, 0, the only way that that can happen is that low point in my parabola is crossing or hitting the x-axis. So there's a graphical, there's more things to flesh out about this graph, but just knowing about the x-intercepts, I can at least visualize what I'm going to see. This one and this one, since they had 2 x-intercepts, well, again, we have a parabola. There's one in this case about negative 0.14 and negative 1.52. So this parabola is going to be crossing the x-axis twice at those 2 locations. And then this one that's pretty nice, right? So you have negative 1, 0, and 3/2, 0. So this graph also, when I graph the U shape, is going to be crossing the x-axis at two very nice locations. So that's basically the graphical connection behind what we've been doing in this section. So we're making a prediction, what number and what type of solutions do I have, and then that prediction will tell us we have two nice zeros, which graphically means I have two very nice x-intercepts. We have two not nice, right, real solutions, which means I have two not nice zeros, but I'm still crossing the x-axis twice. I have one real zero, one rational zero, so I have a nice location where I'm crossing the x-axis. Or we have no x-intercepts at all. So my graph is above, or in some cases we end up being below, all right, the x-axis, and it never crosses it. So you can actually use a picture also to determine what the discriminant is. So in these two cases, the discriminant, if you didn't know all this behind it, just looking at these two pictures, I know my discriminant has to be positive because I see it actually crossing the x-axis twice. In this one, the discriminant would have to be 0 because I only see it crossing the x-axis once. And over here, b squared minus 4ac would actually have to be less than 0 because I don't see it crossing the x-axis. So we can actually visualize a parabola and automatically know what's happening in the quadratic formula. The discriminant is going to be positive because I see two x-intercepts. The discriminant is going to be 0 because I only see one. Or the discriminant is going to be negative because it's never crossing the x-axis. So there's a visual way to also see what the discriminant's doing and predict some things with regard to solutions. All right, so that pretty much sets the stage. We're going to wrap up this summer by looking at graphs of quadratic functions. See you guys in that next video.